So this last session is on solar panels, reuse and recycling infrastructure needed from 2022 to 2028. Our moderator and presenter that's going to go over this today is Robin Ingenthron with Fair Trade Recycling and Good Point Recycling. And we've had the pleasure of working with Robin on a number of different electronic waste issues over the years, and it's good to have him down from the Northeast. So Robin, I'm going to turn it right over to you, sir, and let you run with it.
Okay, thanks, Gene. I know it's nice outside, so we'll try to do this as short a version as we can. But just to pick up where Gene left off, I was the division director at Massachusetts Department of Environmental Protection in the 90s, where we set up the first cathode ray tube waste ban in the United States. And our commissioner, David B. Strews, wound up leaving Mass DEP to come down and supervise Ray over here. And that's how we got connected with SWIX, because we had an infrastructure plan to try to set up and use the reuse value of CRTs back in the 1999, the early mid-2000s, counting on enough of the CRTs being reusable to offset the very expensive costs of recycling them. And that worked out really well, so well that when my wife got hired as a college professor, I had to quit my job at the state and follow her up to Middlebury College in Vermont, where I was forced to use my CDL to start my own company, Good Point Recycling, which now has offices in Middlebury and Brockton, Massachusetts. So I'm starting with that because a lot of what you're going to see is familiar. In fact, the CRTs, I went overseas and found that the factories that originally made them and were reassembling them were at that time buying them back for $10 a piece. And these were factories with up to 1,500 employees. They knew that the cathode ray tube was worth, a brand new one lasted 25 years and cost them $110 a piece. They were perfectly happy to buy ones that had only been used for 3 or 4 years, remanufacture them right back in. Okay, what happened to the flip phones? Well, right now Africa has got 170,000 mobile phone towers, but had practically no phone sales. Africa had 300 television stations.
Recording in progress.
But never bought new TVs. So this is why we're looking at solar panels, and I'm going to show you why this is going to be familiar. First, a little bit about my company. The presentation is going to be in 4 parts: what the problem is, what the services that we can provide, what the revenue streams are going to be, and how we can make a business model for the solar panels the same as we did. This is our factory up in Vermont, the same as we built a 40-person company up in Vermont through reuse. Today we're still in the reuse. This is our $50,000 a month flat screen TV parts department. We're selling all of these parts, T-Con boards, power supply boards, tuner boards, virtually all of them to American TV repair shops. You think that repair is gone, but $50,000 a month says otherwise. That's a copy of our team, or a photo of our team. This is what we do with those flat screen TV parts. We tear them down, look up the part number, take photos of them, and do the inventory. And what we're now working on is getting those TV parts to Africa and Asia as well, because they repair things even more than we do. Okay, so here's we work closely with a University of Rhode Island German engineering student over the last couple of years who came here to study, to try to figure out how to recycle photovoltaic panels. And he looked me up after spending about a year trying to grind these things up, shred them up, find something of value, And he saw that we were advertising that we took them in Brockton, which was just a little bit north of where we was at in Rhode Island. And so he contacted me and said, you know, I can't make this recycling thing work. You know, I'm getting a little bit of aluminum out of it, but the energy cost of what I'm putting into shredding these things up is higher than what, it's not worth it. You know, it's shredding them up to feel good and maybe causing cadmium to get freed up in the process. So he had started seeing if he could reassemble them to keep the value-added parts kind of like the factories did. And so here's what we learned from him is that right now the cost of siting a new solar field is exorbitant. The Not in My Backyard has started. It's really hard to get a solar field sited in Vermont or Massachusetts today. The penny is not as shiny as it was 10 years ago. What that's going to do, Leonard said, is based on the efficiency of the increasing panels, all of these are going to wind up getting replaced by 2028 because it'll just be economical. The cost is coming down on the panels, and you don't want to go through siding more and more. And there's only a certain number of flat roofs. So here with the red line, you can see where he thinks the break-even point is going to be, where the cost as more and more new panels goes down, and the efficiency, the payoff goes up. So he's saying 2028. Virtually all the solar panels that have been put up in the past decade are going to be what? Flip phones, CRTs. These things are going to start to come into the electronics recycling field with perfectly working, but like what we documented in the 1990s, the cost of reselling computers and used televisions at the Goodwills and Salvation Armies went through the floor. Nobody could make it reselling them in the US. And what that is going to mean is that this payback efficiency is going to cause the price per kilowatt hour. Right today you can get about 40 cents per kilowatt hour reselling them on eBay. But for these older models, by 2028, it's going to drop down to 10 cents a kilowatt, and Americans aren't going to find that worth it at all. Sounds a lot like flip phone sales. Sounds a lot like CRT sales. So that's Emmanuel's hand, by the way, with the Fair Trade Recycling bracelet. He's going to be on here in a minute. What he and I and our colleagues in Fair Trade Recycling, which is a nonprofit trade association that's basically defends the export market from being hammered and blamed by the press. Before the solar panel, before the people even start to say that we're dumping these things on Africa, what we're working on is to backfill this, bulletproof it, and document that that is not what's going on. This was Emmanuel. We got him to go present in the largest e-waste conference in Europe 3 years ago, where he got to explain to all the Europeans that have been very, very frightened by images of e-waste in African dumps. You know, Emmanuel had to go and explain to him that African cities like Lagos and Accra have had television stations since the 1960s and 70s, and that these TVs that you're photographing at the dump were imported in the 1970s. That's a 1971 TV. So Africa does have its e-waste problems, but we're distinguishing between the tech sector, which are the people like Emmanuel, smart enough and savvy enough to have been a valedictorian. If they'd been born in the US, they would be working at Boeing, but they are in the repair sector. And those are the people who are the reason why Africa has 170,000 mobile phone towers. I'll turn this over to Emmanuel next to give you a lot of the presentation via Zoom, and then I'll follow that up with how he and I working together are going to bulletproof this, which is by taking the solar panels that have been turned into Good Point And we're running a 100% off-grid project in Vermont, done by do-it-yourselfers using the same methods that Africa's tech sector will apply. So with that, if we can turn it over to Emmanuel.
Hello, I hope you can hear me.
Yep, you're good.
Awesome. Let me begin to share my screen. All right. Can you see my screen as well?
Yes.
Awesome. So today, I would like to take you on a little bit of history. So we in early 2000s, we've had a lot of. First of all, I want to thank you for the opportunity to present this. I don't take it lightly because in so many quarters, decisions are made, stories are told about Africa and Africans, and we never get the chance to tell our story. So I don't take these opportunities lightly. I thank you so much, everyone who's been instrumental in putting this together and inviting us to speak on this subject. I want to thank you. So back to my presentation. In 2015, the UN EP issued a report, and they use a few photos, about 8 of them, that are taken basically in Ghana, in West Africa. I'm sure a lot of you have heard about Agbogboshi, or the world's largest e-waste dump in West Africa. All those terms were used earlier on. And these presentations, these documents basically have one hypothesis, and it is the media and a lot of channels picked it up, and their thought process is that these photos illustrate illegal dumping by developed countries like the United States or countries in Europe that are dumping these materials into places like Agbogboshi or other places in Africa. Now, those of us who are from the region who call these places our home, our understanding of the issue is very different. We have another hypothesis that states that these photos show that electronics that were imported and used for years and are finally being discarded. I remember when I was a little boy, how I got into electronics and how I got into technology, how I got into computer science is getting introduced to computers. I remember old IBM thick laptops that my dad bought for me, desktop computers with CRT tubes, monitors that my dad bought for me in the late 90s. Those things introduced me to technology. So these things have been in existence in Africa for so long. When I was little, my grandfather, who was a professional photographer, had televisions in his home. We used to watch television when I was little, watching the African Cup of Nations. We used a lot of electronics when I was a young boy. So we are thinking that these things have been in Africa much longer, and that this electronics that we have used in our own homes around Accra or around Kumasi or in Lagos or Abuja, these things are finding their way to the dump sites. So that is our hypothesis, and so we have based on this hypothesis, we see different solutions being proposed. So for the first hypothesis, it says that that shows pictures of kids standing on electronics and fire around them and stuff like this, like you can see in this pictures. Basically says that the junk the kids are standing on have probably arrived days earlier in a sea container, and that the percentage of junk is very high, and that import must be restricted. That is the solution to that hypothesis. And we are thinking differently based on our hypothesis as well. We know that these electronic parts have been are part of electronics that have been used in Africa for so long, we do a lot of repair. I mean, if you go to Accra, every corner has electronics repair shop. So we do a lot of repair. So we know that these materials have been in Africa longer than they've been in Europe or in the United States, and have been repaired over and over and over again. And at a certain point, when you cannot repair anymore, you have certain parts that you can just pull to fix something else, and the rest of it ends up in a place like this. So our solution is that the tech sector that imports this electronics are the best and the brightest in Africa, and we should encourage them to play a role in recycling and through take-back programs and offset programs that we have proposed. Instead of cutting them off from the economy, we can encourage them to teach other people to do the right thing. So who is importing this electronics, you might ask? Well, it is people like these guys, this young man you see in these pictures. This is actually a shop that we work with in Ghana. They import a lot of computers. You can see Apple iMacs right on the left with a lot of Dell computers. They import a lot of stuff, fix them, and sell them, basically. And without these guys, without shops like this, I would not be a software engineer today. These guys are the ones who give opportunity to people who cannot afford a brand new laptop today. Nobody that I know, a regular Ghanaian that I know, will be able to afford a brand new iMac as you're saying it today. Thousands of dollars, never. And so these people provide us these tools that we can learn and us be able to compete and acquire knowledge and work our families out of poverty. So these are the guys who we are calling the tech sector of Africa. Now, we are talking also about power today. So that is a little background, but I want to give you some history about how power issue evolved in Ghana. And this issue is similar to the region. So when you hear this story, just because of time, I don't want to repeat what is happening in Nigeria or Togo or Liberia or Senegal, but the story is pretty much similar. So in the 1940s, the first Ghana government-sponsored public electricity supply commenced in Sekondi Takoradi, which was basically to power the railroad companies that were mining and shipping out resources out of the country. That was it. They wanted electricity to power stuff to get the resources out. That's what they did in 1914. In the 1957s, the Akosombo Dam, which is the largest today in Ghana, was commissioned and was financed partly by the United States and the World Bank. And this was also to power the growing economy, a young independent country. They decided to construct this project also for the other mining industry, but also for the new companies, businesses that are coming up into the country. So the Lake Volta was created, which is the largest man-made lake in the world. Okay, and this was constructed and built by funding from the United States and the World Bank. Well, that provided electricity, and that electricity basically powered African businesses, households in Ghana. We sent electricity to Togo, Benin, Burkina Faso, and even later on to Sierra Leone and other countries in West Africa. Ghana was the hub for electricity. We were sending electricity all over the place. So what happened was that we exhausted the capacity of that dam. And so in the 1980s, the Akpong Dam was also added. It too ran out of power in the 1980s. 2008, a third one dam was built, which is the Bu Dam, which is also in operation today. And that didn't solve our problem. We ran out of power supply. And so Ghana began rationing electricity. So basically how in Ghana we call it doomsaw. Doomsaw is just on, off. So doom is on, off is off, saw is off. So we call it doomsaw. Doomsaw is a very known term in Ghana where they're turning off power just to power some other part of the country or some other part of the city, and then turn it back on for some other people and turn it off for some other people. It's just we are growing so fast, and the supply of electricity is not catching up. Today, only 64% of Ghana's electricity is supplied by hydroelectric power. So you can see in the graph that we have a lot of demand for electricity in the region, not only in Ghana. And so because of the demand, we can tell here that there is actually the internet growth in Africa is super fast. We can see here that from 2011 to 2015, Africa is the #1 spot for growth for internet adoption. We have more cell phones in Africa than in the United States, than in Europe. There is so much going on, being powered. All of this is being powered by the used phones we get, the used computers we get, the used televisions we get. Africa is getting on the map when it comes to technology. And this growth is basically putting a lot of pressure on our electric dams. So this is what a researcher, Francis Kumasor, is saying. He says, we must stop the use of wood coal, which is used for about 80% of cooking. We're talking about the climate change and power supply and cooking. So in Ghana, we use a lot of coal. And he's saying that from the research, they're worried that cutting trees to power our charcoal stoves is just not good anymore. We're cutting, there's so much deforestation. And of course, this has some link to climate change. He also suggested that we must meet the next projected increase in electricity use by using some other means instead of just hydroelectricity or burning fuel. The 2011 plan also requires that solar voltaic panels that are than 45% MQA can be afforded to the regular Ghanaian. So basically, we are shifting from cutting down trees to power our stoves or burning fuel to generate electricity that is we can't even get enough of, to using solar panels and other sustainable means. So the World Bank, the IMF is projecting that from 2020, they projected that Africa's electricity generation is going to be not from oil, not from the dams, but it's going to be from solar, from wind, and other sustainable means. So by 2030, they're projecting that a majority of Africa's electricity supply will be coming from solar or wind. So how accessible is this technology to Africans? We know the cost of power. We know that electricity, solar panels are expensive to build, even though the prices have come down. It depends where you are. And in Africa, where the average person makes less than $1,000 a year, even a $10,000 solar system is out of reach to them. So how are we going to achieve this IMF goal? By supplying a lot of reusable sources of electricity to the fast-growing economies of Africa. We think that it's going to be by repair and reuse, just like we have done with other technologies in the past, as we've done with televisions, with mobile phones, with computers. Those things powered our growth in the past years and are still powering our growth today. We can do the same with power, where we can reuse this older, less efficient solar panels in colder climates like in the US or Europe. But in Africa, where we get a lot more sun, and for almost every single day in the year, those solar panels can be of a better use in that region. So I know we are short of time, but I want to just leave this with you. We've done a lot of work bringing Africa onto the maps when it comes to technology, giving people jobs, giving people opportunity. There are a lot of businesses running on the internet today in Africa, thanks to the use and the repair economies that have helped us to do these things. we strongly believe that we can do the same with solar panels, that we can use solar panels from Europe or from other places where they may be out of fashion, and use those same solar panels to power Africa to the next phase where we can have good power, good, clean electricity supply to our people. What I can tell you is that we must do everything not to miss this opportunity, because Africa's population is growing fast, is young, and if we keep burning coal, if we keep cutting down our trees to power our stuff, then the goals that the world has to reduce climate change will not be attained, because a place in the world is still lacking behind. Let's help Africa, and let's help the young people who are talented, who have proven that they can do this stuff. They can keep up, they can fix electronics, they can repair them, they can reuse them. Let's help them to help Africa achieve that goal, and by so doing, help the entire globe in mitigating the effects of climate change. Thank you very much for the opportunity.
I should have also introduced that Emmanuel got his master's at Georgia Tech in coding, and that he's volunteering here. He's not any longer working in the recycling field. Unfortunately, we lost him to bigger and better things, but that he's still volunteering for fair trade recycling. And we really appreciate having the chance to let Africa's tech sector represent themselves rather than have people like me play great white savior and run around. So his contribution is part of our plan to make sure that this reuse market doesn't get wrecked. But we have one more thing to show you, which is the video that we're about to show, which was our solar enthusiast geek, Trevor from Good Point Recycling, said, well, he'll prove that Africans can do it by taking home the solar panels, even the ones you'll see that were hit with hammers, to render them unusable. And with our other African fair trade recycling colleague, Wahab, who you will also see on the roof, they showed that even in a wintry state like Vermont, that even with smashed up solar panels, that you can still go off grid.
Hi, my name is Trevor DeYoung. I work for Good Point Recycling. I'm a solar enthusiast. I'm all about DIY solar off-grid. This is my single-wide trailer that's covered with about 6,000 watts of recycled solar panels from Good Point Recycling. Ideally, if you're going to get a cracked panel, this is the condition that would be best. If they become too cracked, the opaqueness of the glass can reduce the efficiency. But even so, those panels, if you have space to put them somewhere, they can be used somewhere. It's better to do that than to just shred them. So we're now on the roof of my home here, and I have two solar arrays here. One of them isn't very cracked, and the other one is quite cracked. These are all cracked panels, they're damaged. They still produce electricity, and they're still worth using. So this is my other solar array that's consisting of panels that are in really pretty good shape. The only thing that was wrong with them, the reason why they didn't use them is because the aluminum of them was just slightly bent in a few spots, but it doesn't at all affect the solar panel. There's just one panel in here that's cracked, but it really doesn't perform much less efficient than the other ones. Still make this array is about 4,800 watt array. I'm able to make a substantial amount of energy here. It almost looks like they've been hit with hammers. If you look at some of these spots, they're very sharp spots. They may have been deliberately damaged. There's actually a mixture of two types of solar panels here. These ones with the squares on them, these are called monocrystalline. And then these ones that don't have those square shape on them, these are called polycrystalline, the ones I'm on top of right now. This is capable of producing around 4,800 watts. if I had a load that was 4,800 watts, you can't just produce electricity and have it not go anywhere. So if I had the demand, if I had the loads going, then this would be able to run about 4,800 watts. But every cracked panel is different. You know, every panel doesn't get cracked the same exact way. These are monocrystalline panels. I think each one is capable around like 350 watts. Now that's more, just one is more than enough power to run like a refrigerator. So what I did was I used self-tapping screws here to self-tap into this unistrut, and then use self-tapping screws to attach to the aluminum rail right here. For like ending the array, they're great for that. This is a pallet that holds solar panels. This is a solar panel pallet. This thing is built with a bunch of these pallets from solar panels. So this whole addition here, to show how I recycle things, most of the wood here came from pallets for solar panels. That's what this board is, this one, the triangle there, and the triangle there. Those were solar panel pallets, and I repurposed them. How the solar system works, we just showed the two arrays up there. So I have up here is these wires right here. That's coming from that array over there, and then we have these wires here. That's coming from the array down there. And what's happening is all that power has to combine somewhere. So we have a homemade photovoltaic combiner box right here. This was some sort of telecom box. Like, it didn't have any purpose for this sort of thing. Like, it wasn't meant for this. So I just gutted it, and I found this ammeter at Good Point. I installed that into it. So this is where all the power combines, and then it comes out through this orange extension cord. It goes to this shut-off box that has fuses inside of it. And then from this box, it goes into this right here. It's called the MPPT solar charge controller. This is like the mediator between your solar panels and your batteries. Without one of these, you can't really have a solar system. This is what controls charging the batteries, which are down here. What we have down here is we have 8 100 amp hour lead acid batteries. I think it's about 10 kilowatt hours of total storage, but with lead acid, you can only use about 50% of that, so it's really more like 5. Alternating current is right here. This is an industrial UPS. It came from Good Point. These are used for backing up data centers. There's different UPSs that are used for backing up different things, but I found if you can get an industrial one like this from like a data center, you can use it as an off-grid inverter. So originally, there would have been batteries inside this cavity right here, but what happens is the batteries go bad, and the company will just throw the whole unit out and start fresh. So we get these all the time in our facility. This is able to take the 48 volts of this massive battery bank, convert it to alternating current, which I then have distributed through my house to go to my air conditioner, refrigerator, TV. It powers a lot of stuff. So with the battery bank, you have your negative and positive terminals. What we have here is this is some box that came from the hospital or something. It was for some scientific use. I repurposed it as my positive bus bar box. This is where all the positive connections of the battery bank go, and this is where all the negative connections of the battery bank go. I'm able to get 120 volts AC from this UPS to power things in my house, but then I'm also stepping down the 48 volts of the battery bank with this device right here. This is called a DC to DC converter. This takes 48 volts DC, steps it down to 12 volts DC, which is like, what a car would be. And then it goes into this marine fuse box right here. And then from this fuse box, I'm able to power 12 volt devices, such as this 12 volt USB hub that you would use in an office or whatever. This is also a DC to DC converter. This takes the 12 volts from here, converts it to 5 volts, and then I'm able to have lights here. What I have for monitoring the power here is, these are called ammeters. They measure current and how much power is coming through. I have one, which this is showing the power coming in from the solar, right? So right now I'm making about 915 watts. And We know that we're completely running off solar because this number right here, this ammeter measures how much current is leaving the battery bank. Because this number right here is at 0, it's telling me that all my power is coming from the solar. If this number was to go up, that would tell me that I have a power deficit and I'm not making enough power to keep my batteries charged.
So that means you never use the battery power during the daytime.
No. Like what's happening is this is charging it at such a high rate that the batteries aren't really they're not losing any current. See right now, see how the number right here is back up? That's at 1,000, 1,200. Now we're being completely powered from solar.
So like
Okay.
now it's going back to
If I turn the smart plug on, the internal transfer switch, see how it just clicked right there? Now we're running off the grid. Okay? If I turn this off, we're running on solar. So in order to operate ammeters like this, you need what's called a shunt. And you can find shunts inside of a lot of different electronics that I find at Good Point, like lab power supplies, old UPS systems. So what I did is, if you look right here, this is called a shunt. This device right here. The current has to pass through this shunt, and these wires go to one of these ammeters. One of them is for in. This one's for in. And then this is also a shunt. This is measuring how much current is going out of the system. That's pretty much the system. Right now, I'm currently working on a lithium-ion project from laptop batteries from Good Point Recycling. So what I've been doing is taking laptops, batteries apart, and then I capacity test each and every single cell. I sort them by the ones that are similar, and then what I do is I build these big packs here. Each one of these consists of 100 18650 cells found inside of laptop batteries. Now this is because they're all wired in parallel here. See how all the positives are going to this bus bar, all the negatives go to this other bus bar. This is the positive terminal, that's the negative terminal. These are low voltage, high capacity batteries. So in order to get these to 48 volts, I'm gonna have to wire 14 of these packs in series. But if you're gonna use these, you need to use what's called a battery monitoring system, which monitors each pack for temperature, voltage, and what it does is if one is charging too fast, it'll slow down the one that's charging too fast with a series of resistors, so that the slower ones can catch up. Tesla batteries use the exact same cells. Tesla batteries, it may be different chemistry, but they are the same cells. These are standard size, just like how there's AA batteries, D batteries. These are called 18650 cells. And at Good Point, we get tons of these. We get barrels of them, and we recycle them. But you can repurpose them. You can recycle them.
Thanks, everybody, for sticking around. I could open up for questions, but you could also just catch me at the door if people want to get out of their rooms. Okay, thanks, and everybody have safe travels.
Recording stopped.